Welcome to Brain Vision.
So we're given this equation of a ball rolling down in a straight line, and I'm just going to rewrite this as x of t because it's the same thing. It's a function of time. And the first part is wondering what's the position of the ball at various times. So for x of 1 second, we're just going to plug in for t. So 2 stays the same, 3.6 multiplied by 1 plus 1.1 times 1 squared. And this is going to equal negative 0.5 meters. And then next part, again, just plug in 2 seconds. So we have 2.0, 3.6, plug in 2. And this comes out to be 0.8 meters. And then plug in 3 seconds. Plus 1.1, 3 squared. And this is going to equal 1.1 meters. Now for the second part, we wanted the average velocity over this interval from 1 second to 3 seconds. And this delta v, what I'm going to call, is delta x over delta t. And so this is going to equal delta x. Well, we want x of 3, which is 1.1 meter, minus x of 1, which is minus 0.5 meters. And then we'll divide by the time interval, 3 seconds minus 1 second. And this comes out to be 0.8 meters per second. And for the last part, we want to know the instantaneous velocity at 2 seconds and 3 seconds. And so I can get this velocity function from the position function by taking the derivative. So v of t is going to equal dx of t dt. And so the constant goes away, and we have minus 3.6 plus 1.1 times 2, so 2.2 t. And then to find v of 2, we plug it in again. So plug in 2 seconds, and this equals 0.8 meters per second. And at 3 seconds, it's going to equal, again, we'll plug in 3. This equals 3 meters per second.